Hello everyone and welcome to ASFC Chemistry. This is the first in a series of videos which have been put together by us at the college to help smooth your transition from GCSEs into A-level chemistry. In this first video, I'm going to give you the list of some common ions in A-level chemistry that are so incredibly common, we recommend you commit them to memory as soon as possible. I'm also going to show you how you can combine the cations and anions together to create new formulae that you might not be as familiar with. At the very end of the video, I'll also finish up by giving you a list of molecules that again are so common in the A-level, the quicker you can familiarise yourself with their formulae, the better. Let's get started. I'm going to start here with the cations. Now, these are 9 cation formulae that I really recommend you learn as soon as possible. On the left-hand side, let's have a look at that column first. I've got sodium plus, I've got magnesium 2 plus, and I've got aluminium 3 plus. Now, all 3 of these elements are metals, and so that means they always have to have positive ionic charges. Sodium is from group 1, and everything from group 1 is always going to be 1 plus. Magnesium is from group 2, and everything from group 2 is always going to be 2 plus. And aluminium is from group 3, and so therefore it has a 3 plus ionic charge. In the middle column, silver isn't in group 1, but silver is a metal, and so silver has a 1 plus charge. Zinc has a 2 plus charge. Zinc again is a metal, and you'll find it in the middle of the periodic table. Now, if you look just to the bottom, you'll see that we've got iron 2 plus, and to the right of that we've got iron 3 plus. Some elements in the periodic table are called transition metals, and transition metals will sometimes have Roman numerals coming just after the element that tell you what positive ionic charge it needs to have when shown on its own like this. For example, iron 2 is iron 2 plus, like you can see at the bottom just there, and iron 3 would be iron 3 plus, like the one to the right. The other 2 remaining cations that we need to memorise are hydrogen ions, which is to the top right, and ammonium ions, which is NH4 with a positive charge. The ammonium ion is a little tricky to remember, and it's also very easily mixed up with ammonia. Ammonia, though, is NH3, whereas this ammonium ion is NH4 with that single positive charge. Moving on to the anions next, we've got on the left-hand side O2- and S2- to get started with. Now these are called oxide and sulfide respectively. The IDE in their name tells me that they're going to have negative charges. They're both from group 6 on the periodic table, and that's why they have a 2- ionic charge. The element to the bottom right is nitrogen, and with a 3- charge, we've got nitride as that common ion to learn. In the middle column, we kick off with one of the halogens with a single negative charge, and this is bromide. Can you see that IDE pattern going all the way through here so far? It tells us that our ion is negative, that it's an anion. In the middle column, we've also got hydroxide, again with the IDE, and right at the bottom, chlorate 1. Instantly breaking the pattern. Now, it does end, however, in ATE. So chlorate 1 tells me with ATE in its name that it's negative and contains oxygen. The exception to that rule is hydroxide, which doesn't have ATE, but clearly mentions oxygen in its name. The other part of the chlorate 1 ion's name that's a little unusual is the 1 there, and you might think that the 1 refers to the single negative charge that the structure has. It doesn't. It actually refers to the fact that the chlorine here is in a +1 oxidation state, but let's not worry about that until we're on the course and studying the topic of redox chemistry. The final 3 anions to memorise are on the right hand side, and I'm not going to lie to you, they're the hardest to learn. We've got nitrate, sulfate and phosphate. They've all got ATE in their name, which means they're negative and contain oxygen, but otherwise It's really about practicing the formulae and taking the time to look at how many oxygens and what charge they have each time. Put the time in with these though, and it makes the rest of your A-level a lot easier. So let's assemble some chemical formulae from the examples that we've just been through of the common ions. Take these two for example. We've got a group 1 metal ion, sodium, and we've got a group 7 ion of bromide. The IDE tells me that the bromine here has a negative charge, making it bromide. So if I want to assemble formulae, what I need to do is make sure that all the positives I use equal all the negatives. So here it's simple, because they've got the same but opposite charge as each other, I just need one of each. And so my formula is sodium bromide NaBr. If, however, like this example, we've got two different charges that aren't equal and opposite, what we're going to have to do is find a common multiple of the number and then multiply up the two ions so that we can get the correct formula. For instance, here, I've got magnesium 2+, which is a group 2 metal ion, and I've got a nitride as well. So what I need to have are 3 lots of the magnesium 2+ and 2 lots of the nitride, because the common multiple between the 2 and the 3 is going to be 6. So my formula over here is going to be Mg3N2. My next example is going to be aluminium nitrate when I put this together. And what we can see is we've got a nice obvious 3 lots of this required. However, what isn't obvious straight away is the fact that here I've got a polyatomic ion. Now all that means is I've got more than one atom actually to make up the formulae of this ion just here. So whenever I have that kind of instance and I need a multiple of it in a chemical formulae, for example here I'm going to need 3 of it, I need to put this ion in brackets. So for example, my formula over here is going to be Al brackets NO3 close brackets 3. Without the brackets, it would have actually read AlNO33, which would have been 1 aluminium, 1 nitrogen, and 33 oxygens. That's definitely not what I wanted. What I wanted was 3 lots of this with 1 of those. And that gives me my aluminium nitrate. So check your names so far. Sodium bromide, magnesium nitride, aluminium nitrate. The next example uses an ammonium ion, quite rare, but very common at A level, along with a sulfide, not a sulfate, a sulfide, which is from group 6 with a 2- charge. So I need 2 of this and just 1 of those because I've got a plus and a 2-. However, because I'm going to need a multiple here of this one, and we can see we've got more than one atom making up the ion just here, so it's a molecular ion, or you can call it a polyatomic ion, it's entirely up to you. I'm going to have to use brackets around this one in the formula. So I need 2 lots of the NH4, there we go, and 1 lot of the sulfide. It might seem a little strange to put the brackets at the front, and you could reverse it, it's just we typically stack things, cation component, anion component. For my last example, this one might seem a lot more straightforward than the others, but I wanted to use this to make a point about acids. Here we have our hydrogen ion. Now the hydrogen ion is a common feature of acids. Remember that acids are proton donors, which is represented by an H+ ion. So all acids donate an H+ ion, according to the Bronsted-Lowry theory of acidity. Now the PO43- is a phosphate ion. If I'm to combine these two together, I'm going to need 3 lots of the hydrogen ion just here and just 1 of the phosphate. So again, this might seem a little simple compared to some of the others. And you might be looking at this thinking, well, that's just hydrogen phosphate. But actually what I've assembled is the formula of phosphoric acid. And you can use this as a way of remembering the formulae of your acids or remembering the formulae of these anions if you want. For nitric acid, phosphoric acid, sulfuric acid, and hydrochloric acid. It'll work with all of them. You just have to remember that hydrogen ions paired with those respective ions from the previous page will give us an acid. Finally here we've got some molecules which are very common on the A-level in chemistry. We've got hydrogen peroxide, which is our one to the top left, that's H2O2. Hydrochloric acid just below it, which is HCl. We've got ammonia, which is similar to the ammonium cation that we saw right at the start of this video, and that's NH3, just shown there. In the middle top, we've got CH3COOH, which is actually ethanoic acid. Then we've got calcium carbonate, sodium hydroxide. To the top right, we've got chlorine, which is a halogen. Below it, there's nitric acid, HNO3, and just below that, we've got H2SO4, which is sulfuric acid. All of these molecules come up so often in your chemistry A-level, like the ions before them. It is really important for you to get to grips with these formulae and commit them to memory as soon as possible. It speeds you up with exam questions, it makes it easier to approach new topics, it generally increases your chemistry knowledge. So as quick as you can, get started learning these, maybe screenshot the slides that you've seen already, and make sure that you're testing yourself on putting those formulae together. That's it for our first introductory video. Click the links on screen now to be taken to other videos that relate to A-level chemistry content. And until next time, happy revising.